Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, editor-in-chief at Automation World, and the question we'll be answering in this episode is, do collaborative robots need safety risk assessments? And joining me to answer this question is Devin Murray with Schmersal USA, a supplier of safety switchgear, devices, and systems for personnel and machine protection. Devin works in Schmersal's Technical Engineering Services division called Tec.nicum, which focuses on machine safety, such as risk assessments, validations, and training. So thanks for joining me today, Devin.
Oh, my pleasure. Thanks for having me.
Sure. So, Devin, let's make sure everyone understands, what we're talking about here today. And so let's start, what defines a collaborative robot, which are often referred to as cobots, and how are they different from regular industrial robots?
Sure. So a collaborative robot, as you mentioned, commonly called a cobot, is a robot which is essentially designed and introduced to the industry to work directly with the human operator in a safe manner. Technically speaking, it's a robot designed to work in a collaborative operation, which is defined as a state in which purposely designed robot systems and an operator work concurrently in a space during production operations. Basically, characteristics of a collaborative robot include smooth, round edges to minimize pinch points, slow speeds, and low capabilities, which differs from the typical industrial robot.
So what about safety standards? Because, we hear a lot about, we all know about the safety standards, with the standard industrial robots, and they often have to be caged and, light curtains around them and all that. What about safety standards related to cobot? Are there any of those that have been implemented yet?
Yeah, so typically I've seen with the industrial settings, there were vast advancements in this case with the collaborative robot technology, followed by safety regulations to help ensure a safe working environment. The first documented cobot was introduced in the mid to late 90s, and some of the well-known industrial robot manufacturers that we know today released their versions of collab robots in the early 2000s. In 2012, the standard which defines safety requirements for industrial robots, which is ISO 10-18, which is harmonized to our North American standard ANSI RIA 1506, referenced collaborative robots. And then in 2016, the technical standard ISO TS 15066 was released to provide further guidance on safe implementation of collaborative applications. So yes, there are definitely standards and regulations in place today.
Okay, so it's not a gray area anymore, like it was a while back, where I can remember some discussions of that. It's like, yeah, it's safe, you can do this. It's got all these protective mechanisms on it, but OSHA might see it differently. So
Yeah, now
there are.
there's things in place now for sure. Yeah, yep.
So since cobots are, designed to be safe for humans to work alongside, I mean, that's their whole purpose and intent of these types of robots. Are risk assessments of a cobot installation needed before work begins?
Yeah, so referring back to ISO TS 15066, which I just mentioned, it clearly calls out in black and white that a risk assessment is necessary to identify the hazards and risk associated with a collaborative robot system application. You'll read that the integrator shall conduct a risk assessment as described by ISO 10-18 and ANSI RA 1506. So yes, a risk assessment is absolutely needed for a collaborative robot application.
It has the word shall there.
Shall. Yeah.
Shall
Yep.
means will, should, and
Must.
all
Yeah,
of
we
the
must
above.
do
Yeah.
it. All the above.
Oh, absolutely.
Yeah.
So, based on your experience, what are some hazards that are common or often overlooked when it comes to users implementing cobot applications?
Yeah, the risk assessment I just mentioned is commonly
Mm.
overlooked for sure.
Oh, okay.
I would say typical application hazards: impact, crushing, trapping, projectiles, and I say these typical hazards because they are often overlooked once the term collaborative robot is used. I mentioned earlier about smooth edges, minimizing the pinch points, slow speeds, and low payload capabilities. And sometimes that's taken as this is a safe piece of equipment and all is good. So those typical common hazards are missed, but this is why a risk assessment is required. So we got to look at the loads, the materials, the robot torque. One of the biggest overlooked hazards I've probably seen is the actual cobot location. So you have to look at, are you creating a crushing or a trapping hazard with the cobot in a fixed surface, or is that cobot positioned high enough where it can come into contact with an operator head, which
Mm.
is not allowed at all.
Mm.
So
Okay.
I would say the risk assessment, those basic ISO 12100 hazards, and the position of the cobot are commonly overlooked.
Okay. And you mentioned too, there just a side question off of this is you mentioned that the risk assessments are often overlooked with
hmm
cobots. Is that something that's particular to cobots based on what you've seen, or is this something that's often kind of overlooked for other industrial machinery as well?
Yeah, so I would say it's often overlooked, but more so with the cobot, just because of that misconception that it's inherently safe, so we're good to go. So risk assessments, in my experience, are typically overlooked, but I'm seeing it more so with cobots nowadays.
Okay. So, are there any options that you recommend to help ensure safe cobot operations alongside humans?
ISO TS 15066 defines four methods of collateral operations, which would be safety rated monitor stop, hand guiding, speed and separation monitoring, and pressure and force limiting. And if we look at each one of those individually, safety rated monitor stop is when you have the collaborative robot motion stopped while the operator is within that collaborative workspace. With hand guiding, we see more of a collaborative operation. The motion of the collaborative robot is controlled completely by the operator. And this could be during a point based teaching where the operator is showing or programming the robot for a defined motion or path. And this can also be seen with applications such as with a lift assist, where an operator is guiding a robot arm while moving a payload. For speed and separation monitoring, as the human approaches the cobot will decrease its speed to a slower, safe pace. And once the operator enters that defined protective distance, the cobot will enter into what's called a protective stop. For pressure and force limiting, we see that collaboration where the operator is working, shoulder to shoulder with the cobot. You have identified that there will be contact with the cobot and operator either by accident or on purpose. And as such, the cobot pressure and force must be limited so that it will not exceed the allowable thresholds as defined by the standard. ISO TS 15066 looks at different regions of the human body and lists the maximum pressures and forces allowed, what can be experienced by the operator, and what cannot be exceeded by the cobot. Now, my explanations of these methods are simplified to say the least, but the standards say you have to select one or more of these methods depending on your application to help ensure a safe operation with cobots and humans.
Yeah, yeah. Obviously, your answers were, basic and structured down
Yeah,
and stuff, like because each of these could
mm,
be books on their own, of course. So,
exactly, exactly.
yeah. So,
Yeah.
Speaking of that, let me ask you about a side question about one of those you mentioned, the speed and
Mhm.
separation monitoring. I've been seeing quite a bit about that over the past few years now, in terms of because that's being applied to industrial robots to allow them to operate collaboratively. Again, based on your experience, as a risk assessment, machine safety, expert in this,
Mhm.
do those seem to be as effective in enabling industrial robots to work collaboratively as your standard collaborative robots that are designed as such from the get-go to operate alongside humans?
That's very dependent on the application, right? So
Okay.
going back to one of the first things we spoke about was the design of the collaborative robot, where again we have those smooth edges, the slow
Mhm.
speeds, and the low payloads, where the industrial robot was designed and put into production to handle those tasks, which are not really acceptable for the human, or not
Mhm.
for human not to be able to do. So when you look at those typical applications, they are inherently dangerous to the human, to the operator. So that's one of the reasons why you would typically see those industrial robots fully engaged with the fencing. Now again, it completely depends on the application, right? Because you can have an industrial robot that's doing a task that is of a slower speed, perhaps, or using or moving a payload that's not dangerous, where you can incorporate a laser scanner, like you mentioned, to do a speed and separation monitoring. So you can definitely apply some of these collaborative robot methods to industrial robots, but it completely depends on the applications. And more than likely, when you start looking into like speed and separation monitoring, it's going to fall back into the collaborative robot realm.
Okay. Well, it makes sense, and I guess it's not too surprising. After all these years covering automation, it's one of the things I find out when I ask questions like, "Well, can this do that, or this do that, or will this work here?"
Hmm.
It's like the answer almost 90% of the time is it depends.
Right,
It
right.
really does depend on the application and where it's at, and yeah,
For sure,
there's
for
lots of things
sure.
to consider. So, Devin, is there anything about these cobot safety standards that we've been speaking about that are more difficult to implement than other machinery risk assessment procedures?
I mean, at the core of every Type C standard, such as the ISO 10218 or a safety specification like the ISO TS 15066, lies the same method or approach, right? It's identify the hazards, identify the risk, and then use this safety standard or document as a guidance to design safe measures. And that aspect, the cobot safety standards are just like any other,
Mhm.
but what makes it unique and perhaps slightly more difficult is the fact that contact with the point of operation, or with a moving machine, which is the cobot, can be expected and accepted, which is different than most other city standards, where the main goal is to guard against the point of operation. So being able to validate and document the justification for one of the four methods we just spoke about, to say that you're going to allow the human and cobot to work concurrently together in the same workspace, is probably the most challenging, especially if you're looking at something like pressure and force limiting, where there are no other protective safeguarding measures like a scanner or a light curtain. And so that can be difficult, but the implementation is definitely achievable.
So, one last question, Devin. Considering everything we've spoken about here today, would you say that collaborative robots are safe to use?
I would say that if implemented correctly, collaborative robots can offer a safe means to many industrial applications. You just have to remember that even though collaborative robots were intended to be inherently safe, a collaborative operation is only as safe as you make it.
So, again, it depends.
It depends.
Right? It depends.
It depends.
All
For
right.
sure.
Thank you again for joining me for this podcast, Devin. And thanks, of course, to all of our listeners. And please keep watching this space for more installments of Automation World. Get your questions answered. And remember, you can find us online at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.